Well, good morning, good afternoon, or good evening, wherever in the world you are. Welcome to our Simio Industry Insights webinar series. Now, I'm your host for today's webinar, and my name is Gerrit Zeeman, and I'm Vice President Manufacturing Digital Twin Solutions at Simio. Our webinar topic for today is redefining the role of forecasting, how digital twins and DDMRP are reshaping supply chain management. Now, I think as we realize more and more that supply chains are actually not a linear chain, as the name seems to indicate, that can be precisely calculated and optimized at all times, but rather a complex adaptive system where the behavior is actually non-linear and the constraints are constantly moving around based on things like disruptive events that may occur, or changes in product mix, or changes in demand. So I think we start to realize that perhaps trying to be more and more precise is not the right answer, but rather to become more adaptive or agile by protecting or buffering ourselves to be more resilient and to maintain our customer service levels when these changes occur, and that might make more sense, right? So with that being said, let's look at the agenda as well as the speakers for today's webinar. Now, first off, we will get into some industry background and case examples presented by Andre Dreyer, Director of OT Simulation at Foresight, a company based in South Africa. Now, Andre has 18 plus years of experience in simulation, but also advanced analytics, business improvement, digital transformation, and he has delivered solutions to clients across the globe. Andre has been a keen Simio user and partner since it was founded in 2007. Now, next we'll look at what is demand driven and why is it game changing. And this will be presented by Chad Smith, who is a co-founder and partner of the Demand Driven Institute, the actual global authority on the demand driven methodology. Now, Chad has 30 plus years of experience in supply chain management and has really been at the forefront of the design and articulation of the methodology. He has worked with leading companies around the world and has authored 7 books on supply chain management. So today we are really lucky to get the demand-driven story directly from the source. And lastly, we will look at a demonstration of a demand-driven digital twin presented by Christine Watson, who is a Senior Solution Specialist at Simio. Christine also has over 30 years of experience in the simulation industry, and she's currently specializing in digital twin technology to optimize manufacturing processes and help enhance decision making across different industries. And hopefully at the end, we will have some time left to take some questions from the audience. So without any further ado, let's hand over to Hanré to get us started. So thank you, Hanré. The floor is yours.
Thank you, Gerrit, for the introduction. So let me start by giving you a quick view of what we do at Foresight OT Simulation. We are part of a larger cluster that focuses on operational technologies and engineering such as automation, instrumentation, advanced process control, manufacturing execution systems, and then, of course, simulation, digital twins, and advanced analytics. At Foresight OT Simulation, we have completed more than 600 projects across 6 continents, where many of them have been in the supply chain or value chain space using the Simio digital twin software. We have seen similar challenges that our clients faced in these projects. Supply chains are complex and highly variable, and therefore typical challenges experienced are long lead times, surplus inventory, stockouts, high costs, inflexibility, and so forth, which results in constant firefighting by planning, operations, and management. The typical supply chain uses forecast-driven planning and is managed using standard MRP systems. So what if a better approach existed? This is what we want to explore today. So before we get there, I want to touch on a few success stories that I believe that most people can relate to. First is automotive parts and the automotive industry. As we all know, vehicles consist of many parts and components that are sourced or manufactured or sub-assembled from various locations. And in the end, they need to be assembled at a central location to build a vehicle, for instance. And secondly, the food industry and food manufacturing. An example again is that you have multiple sources of raw materials that need to be transported, stored, processed, and then packaged and distributed to consumers. And these products and materials typically have some form of time sensitivity, as they might spoil. In the first example, this company did a transformation of their organization and production system, driven by digitalization and integration. Variability was their biggest pain point in production. They required to mitigate the supply chain and process variability and aimed for fixed and stable demand. Implementing DDMRP with a good decoupling strategy and combined with modernizing their manufacturing plants, they were able to reduce inventory by 20% and lead times, planning times, stockouts, and so forth by 40%. The second example involved a complex supply chain with 18 manufacturing sites and 23 DCs. They were hampered by systems and tools that were not sufficient to address their planning and operations needs. They typically used Excel and ERPs. Events like COVID caused significant volatility in the market, and they experienced all 4 aspects of VUCA. They embarked on an extensive business improvement and digital transformation initiative that had DDMRP at its core. They used a simulation approach to prove the concept to decision makers, and it showed significant improvement and validation that DDMRP will work for them. The key focus areas were lead times, service levels, and inventory levels. 2 years after implementing, they had measurable improvements in OTIF, RM service, days of inventory, inventory health in both raw materials and finished goods, and obsolescence. Our third example is from South Africa. This company serviced clients and consumers across the African continent, and their MRP planning did not deliver the required results. In 2018, they also started with offline experimentation and validation in certain regions, and DDMRP showed marked improvements on OOS, OTIF, and their working capital on stock holding. Especially through the COVID pandemic, the DDMRP methodology proved to support resilience and flexibility in their supply chain. Our last example had the challenge of having high capacity to be able to react to the market and also be very efficient at the same time. On the sales or customer side, they had a push strategy, while in operations, that is suppliers and manufacturing, they had a pull strategy, and in the middle sat inventory. Therefore, they had issues with inaccurate forecasts, working capital that was kept in storage, and a push system that was complex. The bullwhip effect also hurt all operations, and therefore inventory was not optimized. They wanted to digitally transform and move their business to a full system, from the customer side right through to the supplier. DDMRP was implemented, and today it is part of their strategic business model and the center of all planning. Among the improvements are OTIF and reduced inventory levels. Most importantly, they achieved operational stability and they reduced loss of sales due to product shortages and rapid adaptation. Furthermore, the sales team had more capacity to focus on the market in order to increase their sales. And now I will hand over to Chad Smith to talk about Demand Driven and why that is a game changer. Thank you very much.
Thank you, Andre. Hello, everyone. My name's Chad Smith. I'm a partner at the Demand Driven Institute, and I'm going to present to you what Demand Driven is and why it's a game changer in today's world. First, let's start with some things that we absolutely know to be true. The first thing is that the world doesn't seem anything like it used to. All right. We put together a list of supply chain characteristics starting with the year 1965, and that's an important year because 1965 is the year that we had MRP. And MRP really hasn't changed from then into today. But what has changed today are the set of supply chain circumstances that we deal with. In fact, the world looks nothing like it did in 1965. It's a world that we call the VUCA world. And VUCA is an acronym that stands for volatile, so that the severity and the frequency of disruption is increasing. It's not a question of if you are going to get disrupted. It's a question of when you are going to be disrupted. The U stands for uncertain. That means it's harder and harder to predict what is going to happen in this kind of world. The C stands for complex. And what that means is we have many, many different nodes of interdependencies. We have so many different connections to manage. Supply chains have elongated while customer times have shrunk. And even small events can have dramatic ripple effects throughout supply chains and supply networks. And finally, the A stands for ambiguous. Now, ambiguous doesn't mean that it's hard to see what is going to happen. Ambiguous means it's hard to see what is happening. We're kind of drowning in oceans of data, but we're kind of starved for relevant information. We have conflicting signals. We have conflicting opinions based upon conflicting data even. So that's the VUCA world. And what the VUCA world imposes on us is two conclusions. First, leadership must start with the basic assumption that big disruptions are going to happen. Next, leadership cannot build business and supply chain models based on profit maximization that ignore the above conclusion. If you have a supply chain strategy or a profit maximization strategy that hopes you aren't going to get disrupted, you are going to be disappointed. So that brings up a question. The question is, how do we design and build supply chains that can assume, mitigate, and adapt to big disruptions? Well, let's build it off a guiding principle, something we call Plausel's Law. And George Plausel was one of the main architects of MRP, and he wrote the second edition of Orlikey's Material Requirements Planning in 1994. And one of the things that he wrote about was what he called the first law of manufacturing. We now just simply know it as Plausel's Law. And what it says is all benefits will be directly related to the speed of flow of information and materials. And it's a simple statement, but what does it really mean? What do we really mean by all benefits? Well, first of all, when things are flowing well, we tend to get high service levels. And when you get high service levels, you have what we call a strong defense. That means your customers, you retain your customers because you're reliable, you're responsive, your customers stay. It also means you've got a competitive weapon. If you're agile and responsive and you can respond in ways that others can't, that means you've got an advantage on the competition. It also means when things are flowing well, you're going to have less course corrections. You're going to have less expediting, less overtime, less additional freight or fast freight. And what that means is you've got less expedite related expenses. It's the death by 1,000 cuts. It's that extra spend of overtime, extra freight, extra warehouse space. And when you add it all up, it goes right to the bottom line because it's cash leaving the organization. And when things are flowing well, what it really means is your inventory is right sized. And I'm going to expand on that in just a little bit. But right-sized inventory means you've got the appropriate level of working capital and you're converting it to cash, which is all the name of the game here. Improved cash velocity. When things are flowing well, the rate of cash generation follows the rate of the product flow to the market. And that then translates to return on investment. Now, as I said, I was going to speak a little bit more about inventory and flow. So how do we relate inventory and flow? Well, we know that there are 2 points of inventory. Let's call it point A, where we don't have enough. Maybe sales is screaming at us. And we also know that there's point B, where we have way too much. And usually we're hearing it from finance. Now, past both of these points, flow breaks down. When you have too little, flow stops. When you have too much, flow stops. So if we know that those 2 points exist, then we know that there's some sort of curve that looks like this with an optimal range in the middle where we're in the best position with regard to our inventory. And what we're really looking for here is a uniform distribution of our inventory positions in that optimal range. Because if we can maintain that optimal range, then we have no shortages or costly expedites. We have less space carrying costs and discounts. Oh, and by the way, we've got good service too. Now, the problem here is that most conventionally planned supply chains have what's called a bimodal distribution. Now, bimodal distribution is 2 distinct humps within the same group over a spectrum. Okay, so what we see is that we've got too much of the wrong and too little of the right. And every time we run MRP, we see a migration, a jump from one side to the other. A few years ago, I was bringing this slide through to a planning team, and they all just started bursting out laughing. And they told me that they had a name for this. They called it ditch to ditch planning. They could never seem to drive straight down the road. They would just carry them back and forth between the ditches on either side of the road. Now, we've been in this game for a while. So we've been doing polling for well over a decade. And 90% of the companies report that they have the bimodal distribution, where essentially you're completely misaligned. Your inventory is misaligned to what the actual requirements are because you don't have a lot in the optimal range and you aren't able to maintain a lot in the optimal range. So the big question becomes, how do we address the issue? Now, what we're going to have to answer are 4 key questions. All right, let's just think about this fundamentally. If we know that the optimal zone exists and we want to keep our inventory in the optimal zone, then number 1, we have to have a way to dynamically quantify point B for stocked items. It's not just a set it and forget it kind of thing because the world changes. So it's got to be a way to dynamically quantify it. We also then have to have a way to dynamically define what the optimal zone is for our inventory and our stocked items. Then we have to have a way to maintain the uniform distribution, a process, a set of tools that allow us to make sure that our on-hand and our open supply are well aligned with demand in that optimal range. And finally, we've got to always have a way to continue to compress the distribution over time for continuous improvement. So those are the 4 things that we need to be thinking about. And fortunately, a method was specifically designed to provide these 4 items in what we call the VUCA world. And that method is what we call Demand Driven MRP. Now, it first was articulated in 2011 in that book to the right, Orlicky's Material Requirements Planning, the third edition. And since then, we've written an entire book on it, and we've written books around it to complement it. It is demand-driven MRP is a model, it's a method, to plan and manage supply chains to protect and promote the flow of relevant information and materials, and it's based upon a whole bunch of different things. It has elements of MRP, elements of DRP, it has elements of Lean, Theory of Constraints, and Six Sigma, and we put it all together. It works together as a package because we have some key points of innovation. But the most important thing is that the bedrock of DDMRP is flow. And it's also that same concept of flow is also the foundation of all of these disciplines we're talking about. Now, DDMRP can best be characterized as position, protect, pull, and adapt. Now, there's 6 components of DDMRP, and those 6 components then create the ability to position, protect, pull, and adapt. And the first thing I want to point out is the very first step is positioning. Now, positioning is all about employing strategic decoupling, and then what we do is we build the protection level at those strategic decoupling points and allow that protection to flex over time. Now, the position and the protection is all what we call configuration or master settings. Then we get into the operational aspects of DDMRP, where we are pulling. We are doing demand-driven planning, and we're doing DDMRP execution. And we carefully separate the planning and the execution, and I'll go into a little bit of that later on. And then finally, we get to the adaptation phase, where we're doing analysis, and then we've got this return loop here that goes back and says, okay, we're going to amend the positioning, or we're going to adjust the protection. Now, let's go through each one of these real quick. With strategic decoupling, what we're really trying to do is knock down the bullwhip effect in one place. See, the bullwhip effect is actually a bidirectional problem. Demand signal distortion moves up the chain, while supply continuity variability moves down the chain. And so what we do is we impose a place, whether it's in the product structure or the distribution network or supply network, where we decouple, and thus we stop the transference and amplification of variability in both directions where it matters most. It's got to be a strategic point. And a strategic point means that it's a source of transference and amplification for the bullwhip. And what that also means is where we decouple, it means our planning horizons shorten and our lead times compress. Now, there's 6 factors that we use to place these decoupling points, to find these right strategic places. I don't have time to go into them all, but essentially what we're taking into account is the market. We're taking into account the external variability and where it impacts us the most. We're taking into account the shared product structure or the entire product structure of our offerings or supply network or our distribution network. And we're also factoring in any critical operations that we need to protect. Now, just if you kind of think about it, this is MRP versus DDMRP. MRP on the left sees everything is coupled together, and it sees a system lead time of 8 weeks, where DDMRP sees the decoupling points and says there's independent short planning horizons and execution horizons. So the critical difference here is that MRP was never designed to decouple. It makes everything dependent, forcing longer planning horizons and variability accumulation. Now, once we have the decoupling points set, we are going to build the level of protection. And the way that we do that is through what we call a 3-zone buffer. And we have green, yellow, and red. Now, it's important that each one of these zones has its own job. The green is your order frequency and size. Your yellow zone is your what we call your primary coverage. And then your red is your safety. And what we do is we combine group settings. So we group parts with like attributes into families by item type, lead time category, and variability category. Then we bring in their individual part properties, and that creates a unique buffer and zone levels for each part that's decoupled, I should say. Just a little kind of an example here is if we had no demand adjustment factor, we have an average daily usage of 17, we have a lead time of 21 days, and we've got an order multiple of 300, and then we've got our buffer profile assignment of PLH. We can populate these zones very easily to get the entire buffer value. Now, a critical difference here with MRP is that MRP wasn't designed to manage stock positions. It was designed to be a perfect make-to-order calculator. So MRP always nets to zero. DDMRP never nets to zero at the strategic decoupling points, and that's the most important thing to maintain flow. Now, once we set the levels don't stay static. They adjust naturally as certain elements are recalculated. Maybe it's the rate of demand, maybe it's the lead time has changed, maybe they've moved from one profile to another, but the buffers flex up and down as required. Or we can manually intervene and impose what we call a dynamic adjustment factor to deal with a promotion, to deal with seasonality, maybe even a planned shutdown. So we can manipulate and shape the buffer based upon what we know or plan to have happen. Now let's get into the operational aspects of DDMRP, and let's talk about the planning engine. This is how we generate supply orders. The first thing that we have to understand is that conventional MPS MRP planning, the activity revolves around a forecast. Whereas in DDMRP, supply order generation actually revolves, the demand component revolves around an actual sales order. And so what that means is that a sales order is actually highly accurate because it's an explicit expression of need from a customer versus a planned order that was based upon and driving supply order activity based upon what we thought the market might want. Now, we're going to continue on with the supply order generation with the full equation, and we're going to show you how this type of demand, how the actual sales orders are used. So every planner and buyer every day, what they're trying to do is answer 4 questions. The first is, what's coming to me? The next is, what do I have? Then it's, what demand do I need to fulfill immediately? And then what future demand is relevant? Now, we use something in DDMRP called the net flow equation to answer all 4 of these questions. And we run that net flow equation every day against all decoupled positions. Now, that doesn't mean that we're going to be ordering against all decoupled positions every day. We will be issuing orders every day for the most part, but against a wide array of positions. Now, the net flow equation is really simple. It's on hand plus open supply minus qualified sales order demand. And when that yields a position in the yellow zone, we issue a supply order in the quantity to get it up to the top of the green zone. Now, how do we qualify demand? It's real simple. We use past due, due today, and any qualified spikes. And the way that we qualify a spike is we use a horizon and a threshold to see what future demand is going to get us into trouble. The rest of the demand, the rest of the sales orders are disregarded for today's net flow equation because they represent fairly normal demand. And by the way, that's how we built the buffer, based upon a normal rate of demand. So in a way, they're already accounted for. Now let's get to DDMRP execution. A DDMRP execution really changes the game for planners and even the shop floor. What we do is we use easy to interpret open supply priorities based upon color and percentage. And what we're saying here is it's a percentage of your safety remaining. So this PO 81987 only has 27% safety remaining. Now, the critical difference here is MRP is priority by due date, DDMRP is priority by buffer status. So it creates a completely different view for the shop floor based upon dispatch lists, where most of your dispatch lists are prioritized by due date. That's on your left-hand side under MRP. But on your right-hand side, what you see is a DDMRP view, and you see that regardless of date, we're sequencing by the on-hand status, the safety remaining in the decoupling point. Now, really what we're designed to do here is when we've got that mechanism that's going to keep us in that uniform distribution, you're going to say goodbye to the bimodal distribution. It's proven to allow companies to plan and execute in the optimal range at strategically chosen points, and that means flow is protected. So thank you very much. I'm going to turn it over to Christine to bring you through an adaptive digital twin in Simio.
Thanks, Andre and Chad. Now let's talk about Simio's digital twin architecture. A Simio digital twin brings a system to life. It's object-oriented, data-generated, and data-driven, and what that means is it allows us to start with an object such as a resource, like a machine, a worker, or a vehicle, and that object can be enhanced to include processes like the movement of materials between different resources and decision logic. Objects can be built from other objects, such as multiple resources and processes to represent a portion of or an entire factory and associated warehouse. The digital twin can also be enhanced to include multiple facilities in an entire supply chain. Objects within the digital twin can be added and changed simply by importing new data. That makes the model easily scalable, and we'll discuss this shortly. This object architecture makes model building flexible and easy to build and share projects. Now, regardless of the scope of the digital twin project, whether it's processes and resources within a single production line or an entire supply chain, Simio includes dashboarding of results and analysis, including experimentation, scheduling capabilities within the operational, tactical, or strategic windows, AI tools such as neural networks that are embedded within Simio, Demand Driven MRP replenishment policies and calculators, as well as the use of Python that provides the ability to transform data, optimize with machine learning, and develop custom steps with specialized heuristics. Next, let's explore a Simio digital twin, first with a very simple example of a factory and associated warehouse to explain and show the demand-driven concepts. And then we'll expand to a supply chain example with 2 factories and a distribution center to show how easy it is to scale the digital twin model by simply importing new data. We're now in Simio looking at a digital twin of a single factory with a warehouse where all of the inventory is stored. We'll look at the animation at work in a few minutes, but let's first discuss the general process. In this factory, we produce and sell 2 finished goods, finished good A and finished good B. They're different only by the paint color applied. We've decoupled at each of the materials in the system, that is, at the raw materials, including the paint, the 2 subcomponents 1 and 2, the final assembly of those components, as well as the finished goods. This helps us to buffer against variability in the customer demand and supply chain. It protects all the lead times at every point in the system, and we can later experiment with different decoupling points and other demand-driven master settings to see what works best for our system. Now, when we ship a customer order of a given finished good, if the net flow for that material goes below the calculated green zone, we generate a manufacturing order for the quantity up to the top of the green zone for that finished good. This continues backward down the manufacturing line of subcomponents. Final assembly falls below green, a manufacturing order is generated for more final assembly, which requires components 1 and 2, and so on. When the net flow of any raw materials fall below the green zone, we generate a purchase order for the supplier. We've now moved into 3D and we're going to run the simulation. I can start it running. And you can see the various orders flowing through the system. I can rotate around so we can see all of the various animation components. I can zoom into the subcomponent manufacturing and you'll see the raw materials inventory and finished goods inventory posted on the walls. Animation components can also be posted on the floor, like in this case. If I put it on pause, we can see that we've got our subcomponent manufacturing here. We have an order for a quantity of 20 at the drill. And I can continue running or go fast forward to the end of the simulation. The animation components of the factory can be as simple or detailed as you like by using Simio symbols or by importing from any factory layout or symbol graphics created in tools such as AutoCAD or SketchUp, as well as repositories such as Trimble Warehouse. We also have bidirectional integration to Omniverse from NVIDIA for an immersive near photo quality 3D animation. Remember, a digital twin model is both data generated and data driven. So let's take a look at what that actually means. We start out with a standard data structure where data is imported into different tables from systems such as an ERP or MES. The resources table actually generates and drives the main resources in the model, cut, weld, and so on. And by changing the data in this or any of the tables, we can completely change the configuration of the factory or the system being modeled. In the materials table, we've got our finished goods, subcomponents, and raw materials. Routings and bill of materials tell the manufacturing area what materials are manufactured or assembled. Our sites include our warehouse 1, which is where all of the inventory is stored and is also where our customers are placing their orders. Now, the inventories table is one of the most important tables for the demand-driven MRP master settings. It includes the connection of those materials to the site or location. And in this case, a single warehouse where all of our factory materials are stored. It also includes information about replenishment, and we talked earlier about how we've decoupled at each one of these materials, and so the replenishment for each of those is demand-driven MRP, but alternatively could be min-max, reorder point, or a custom reorder condition. As I move further to the right, you'll see the decoupling point option, so we can turn on and off which materials are decoupled. Our lead time, minimum order quantity, and desired order cycle, which of course go into the calculations for the buffer zone sizes. Our buffer profile key, which we'll look at in just a minute. And our average daily usage calculation type. In this case, we've got blended, but it could alternatively be forward or past. And we've got past and forward horizon and weights, as well as some qualified spike demand factors. Sales orders is a table that tells us what sales orders are coming from customers. So our finished good A and B being ordered from the warehouse. We'll come back to these additional manufacturing and purchase order tables, stock transfers for the larger example, and we'll talk about those in just a minute. Let's spend a minute talking about the specific demand-driven data and tables for demand-driven MRP. So the demand table includes the past, future, and forecasted demand for each material in the system, including our finished goods, but also subcomponents and purchase materials. Buffer profiles gives us an idea of what our lead time and variability factors are. We have a demand-driven MRP ribbon at the top that allows us to manually calculate average daily usage, decoupled lead times, the buffer zone sizes, and qualified spike demand. But by default, those calculators happen automatically when we run the simulation or an experiment. Got our tables, average daily usage, decoupled lead times, buffer zone sizes, as well as qualified spike demand. And you can see how the zone sizes can vary from one day to the next, and we'll see that reflected in our results. Now, our manufacturing orders and purchase orders in this example, these are output tables, and that means when we run the simulation, these table data are automatically generated. These tables include the orders as suggestions or as actual orders for execution based on how Simio is implemented, either in a predictive or a prescriptive manner. It's important to also note that in this example, this example comes with the Simio software and includes the DDMRP tables that are hard-coded, as well as other supporting tables for employees, vehicles, and so on. And you can change or add to these tables as required for your environment. Next, let's take a look at our results. Because Simio is a simulation and scheduling tool, when we run the model, a resource Gantt is generated to show how busy the various resources are and when orders are expected to start and end. We can zoom in to see the various orders that were processed, subcomponents, final assembly, as well as finished goods. And when these orders are done, they're placed into inventory buffers for each specific material. Now, there are a lot of customized dashboards that have been designed using the demand-driven methodology. Dashboards bring everything to life. They make understanding what's going on in the system simple, visual, and dynamic. And so we'll spend a few minutes taking a look at some of the key dashboards to understand what they mean and who in the organization may be looking at each. So our buffer status planning is used for planning purposes, so our planners would be looking at this because it shows when to order. So when our net flow, our black line here, falls below the green, we order up to the top of green, so it tells us how much to order. It also shows the quantity in stock, which is our blue line. And the key thing to note here is that the inventories automatically adjust based on the changes in demand. So you can note the variability in the top of that green zone. So when the demand changes, demand-driven MRP methodology adjusts for that, and it's all calculated and tracked within Simio automatically. Here we're looking at finished good B within the warehouse, and alternatively we can look at the various other materials in the system. We have our planning screen, again used for planning purposes, and this is a spreadsheet version of the buffer status planning. It's daily for every material. We can see the net flow, our order recommendation, top of the various zones, but also calculates what's called a planning priority, which is the net flow position divided by the top of the green in percentage. So we can quickly look at what materials need to be expedited, those in red, or that need to have action required on a daily basis. And we use this also for dispatching at the different materials for specific resources. So in this case, finished good A and B, we can see that A is red, so it needs to be expedited, and it would be dispatched ahead of finished good B if both need to be painted, for example. We've got a buffer run chart. So this is more like our quality control chart for those quality folks looking at graphs in the factory. And the idea here is to stay within the green zone around the target. And it shows us really how well we're doing as time progresses. So the red area at the top is a little too much inventory. Red area at the bottom is too little inventory. And similar to that, we have our inventory target ratio, and those ITR calculations are based on the quantity in stock and the nominal, which is that average gray dot that we just looked at, and it's similar to a spreadsheet version of that buffer run chart. We can see those ITR calculations in both units as well as dollars. Further, we've got our warehouse capacity. And so the warehouse managers can look to see what the warehouse will look like over time to make decisions. The site object that we showed in the data tables has a maximum capacity that is really just used for display purposes to show where our capacity is and how much capacity is being used. But this can be used by those warehouse folks to identify potential issues, such as here later in the month when we might be exceeding capacity, what kind of steps might be taken. We've got a number of costing dashboards, and one that we'll look at is our inventory cost by material site. So our financial folks might be interested in these financial information, both from the inventory as well as resource costing. And we can look at those daily in this case, and by any specific material. We have a constraints Pareto. So for the manufacturing engineers and process improvement folks, it shows us where our longest delays or waits are occurring. So it might be a resource area, maybe the availability of a resource, material, waiting for materials out of stock perhaps, or even vehicle or truck type pickup. So for example, pick up from our suppliers to move those via truck. And one of the last ones we'll look at in this example is our sales order revenue that we can look at daily, weekly, or monthly. And so again, for our financials and for our managers, we can also look at the number of orders that are on time and just our general sales order forecasts. Now that we've taken a look at some of the results, let's talk about experimentation. So when we're in the process of implementing DDMRP, evaluating various demand forecasts, determining where to place our decoupling points, or even adding new equipment, Simio experimentation can be used to evaluate the KPIs in our system under different operating parameters. Now, in this example experiment, we've set up the inventories table with different configurations of master settings data. So we've got our base case, which is the data we just looked at with all the materials decoupled, plus a scenario where the final assembly material is not decoupled, another where the minimum order quantity, or MOQ, is set to 50 for all of the materials, and then one where the buffer profile is manufacturing, medium lead time, and medium variability. And finally, a scenario where we use reorder point and quantity instead of demand-driven MRP. Now, the user can define KPIs, and we've picked just a few, including our on-time orders, on-time percentage, and some costing information such as sales revenue and gross profit in millions. And we can set upper and lower bounds so that they'll be highlighted, like here in red. Anything below 95 would be highlighted in red. And that makes it very easy to see what scenarios meet the KPIs expected for the system. Now, these are just 5 scenarios that we've looked at, but the key is to pick which master settings, things that you may change, and Simio experimentation is a great mechanism to optimize those parameters and settings based on the KPIs in your system. Finally, let's look at a similar yet expanded example that includes 2 factories and a distribution center, as well as more equipment for processing in the facilities, workers, and finished good trucks. We're using the same object and data architecture, but by changing the data within those, adding more sites and resources, adding a few more materials, we've easily expanded to this supply chain example. Now here, orders can be placed by customers either from the DC or from either of the factory warehouses. And then transfer orders will be generated by Simio for moving material from the factories to the distribution centers. Let's take a closer look. Here we can see the additional resources used for processing. We've got finished goods C and D, in addition to our original 2 products. If I look a little closer, you can see we've got a workers at final assembly, and we've got some at the weld as well. We've got 2 suppliers now instead of our single supplier, so one for paint and one for pipe and sheet metal. And Factory 2 has a similar configuration but operates completely independently from Factory 1. We've got our distribution center, and because it doesn't have manufacturing, that's why we have the transfer orders from the warehouses. If I fast forward, we'll take a look at the data and results in just a minute, but this is an example of an end-to-end supply chain. And although it's very simple, it illustrates that you can apply demand-driven MRP to just the suppliers or within the manufacturing area or factory, or to just the distribution area, which is also called DDMRP, or in this case, end-to-end for the entire supply chain. Now remember, when the customers order from the DC, transfer orders are generated to replenish from the warehouses. And when the warehouses require more inventory at each decoupling point in the factory, manufacturing orders are generated. And then finally, when raw materials need to be replenished, we resupply by generating purchase orders. And the key here is that while traditional replenishment options such as min-max, reorder point, and order up to use manual settings to determine the safety stock level, as well as the reorder level and quantity, while in contrast, DDMRP buffer zone levels, as well as the reorder point, reorder quantity, and the timing of the order automatically adjust based on the actual demand or average daily usage. So let's take a look at the new data for a minute and see what the results look like. So within our resources table, we've got our Warehouse 1 resources as well as Warehouse 2 resources. In materials, we've added paint C and D for our 2 new finished good products, finished goods C and D. Our sites, in addition to Warehouse 1, we have our DC and Warehouse 2. And of course, in our inventories, the pairing of the materials with the Warehouse 1, Warehouse 2, as well as our 4 materials that are stored at DC 1. Sales orders are similar, Warehouse 1, Warehouse 2, and from the DC. And then in addition to our manufacturing orders that generate manufacturing orders for both of the factories, our purchase orders now from 2 suppliers, we have our stock transfer orders that tell us when to transfer materials from each of the warehouses to the DC. Now let's take a look at our results for a minute. We've got our resource Gantt, so you can see our components being manufactured both at Factory 1 as well as the resources within Factory 2. And our dashboards are easily scalable because it automatically includes by site. So we've got finished good A and the various finished goods at the DC, as well as Warehouse 1 and Warehouse 2. And note that those buffer profiles and net flow on hand and so on are all completely independent of the site as well as the material. Now let's take a look at one of the dashboards that we hadn't seen before, but it's available in either one of the examples, and that's the resource utilization summary. So within the plants or within transportation, we may want to look at this. So we've got our transportation, our vehicles, finished good trucks 1 and 2, as well as our raw material truck, but we could alternatively look at each one of the warehouses, both employees and the resources within each of those. Next, we can look at the warehouse capacity one last time, and here you'll note that each of the warehouse managers can look at their warehouse capacity and the usage on a daily basis. Now, for some final thoughts, let's transition back to a couple of slides. The demand-driven MRP methodology, together with the Simio digital twin, allows us to apply this methodology within Simio to optimize master settings for demand-driven MRP and operate in the relevant time range. So in the last few examples we've looked at, we've seen it run in the operational window, so the next 4 to 6 weeks. And we can look at things like planned short-term schedules. We can also use that same digital twin with longer-term data within the tactical window to evaluate things like promotions or marketing events, Can our system handle that extra demand of a promotion? And similarly, that same digital twin can be used within the strategic window, or a year or more out, to evaluate things like new product introductions or the opening of a new regional distribution center. Now, Simio is fully certified in all 3 levels of software compliance, and it's the only discrete event simulation and digital twin software to be fully certified by DDI. Thank you very much. That's all I have from my side today. Garrett, I'm now going to pass it back to you to see if we have any questions from the audience.
Thank you very much, Christine. This was great. Also, thanks to Chad and Andre. Yeah, we just got a few minutes left, so we'll see how much questions we can do. We might even run a little bit over time if we can until we run out of questions. So let's look at the first question. So if a company uses DDMRP for their manufacturing inventory, does it require that upstream or downstream companies that feed the supply chain, suppliers and the distributors, also use DDMRP, right? So if I sit in a chain, does everybody in the chain need to use DDMRP, or can I just do it independently by myself and get the same sort of gain? So I think I'm gonna, Chad, I think I'm gonna pass over to you as the expert on this to give some feedback.
Well, it doesn't require everyone in a chain to participate. I think, would it be a good thing? Yeah. I mean, that's the one thing that everybody wins in a supply chain when flow is promoted. It's that simple. Suppliers get more orders, you get more orders, and also there's major cash implications, not only in terms of cash leaving the organizations, but cash coming into the organizations when flow is promoted at all levels. With that said, you can absolutely do DDMRP without the participation from suppliers or customers. Once you get good at it, what's going to happen is your suppliers are going to start asking you why you're ordering differently. That's going to be the first question, and that's your, kind of open door or crack in the door to walk right through it and start sharing with them about what you're doing and how to collaborate. On the customer side, what they're just going to see is better service, more reliability, and it offers opportunity to extend into that customer entity or that distributor, the idea to bring DDMRP to them, even through a vendor managed solution. But I've seen even the tiniest companies in aerospace do DDMRP. So they're sitting with maybe Boeing or Airbus at one side and then some major supplier, and they're just maybe a tiny composites company. They did DDMRP and but were rewarded extensively from their customer. So the answer is no.
All right. Let's go to the next question here. How do you handle at a decoupling point too much inventory being stored? If you have calculated the buffer red yellow zone size, can these sizes be changed, and how it's best to know what's going to work best for your system, right? And how can this help companies deal with disruptions, shutdowns, and so I guess it sort of says is how flexible is DDMRP and how do we do that? So I think, Chad, just from a methodology perspective, I'm going to pass to you, and then perhaps Christine can respond from a digital twin side.
Yeah, I think the whole method is designed to adapt to conditions, whether it's what we call recalculated adjustments, which are automated adjustments based upon changes in rate of use, or maybe a migration to a different buffer profile. But we also have what we call planned adjustment factors, which are manual manipulations or manipulations of the buffer based upon what we know or plan to have happen. That could be a plant shutdown, that can be a promotion, it could be seasonality. This is that adaptation side of things that we talked about, how it comes and returns, and then we reconfigure. Christine?
Yeah, and so to kind of build on that, what we saw in the demonstration too was that we can use experimentation in Simio to be able to evaluate those kind of things, because sometimes you might look at the buffer zone sizes and the results of what you've initially set up with your kind of your initial master settings, and not really be sure if that's the best the best settings and so on. And so that's where the experimentation can be super helpful, to look at, your exact KPIs. Do I need to adjust, for example, the buffer profiles? So, or adjust the how the ADUs are calculated, any of those master settings that Chad had talked about. And we didn't get into it in the software, but we've got, as Chad mentioned, the planned adjustment factors. So for things like those preventive maintenance or weather disruptions, you can adjust the red, yellow, or green size manually for a certain period of time for those type of things, or for even as we mentioned, for promotions. If you know you have a promotion, perhaps you might build ahead and have a demand adjustment factor for a few weeks to kind of build up that inventory so that you don't run into any issues. So again, the experimentation within Simio is super helpful, and having the digital twin to be able to do those, play in that sandbox and change those things and see how they affect your system is super useful.
Thank you, Christine. All right, this is the next one. Oh, so as we continue to an increasing VUCA world with companies like Amazon that can deliver items same day, do we have to reschedule daily or weekly based on forecasts? So I think that's sort of the classic one, right? Do we need to rapidly sort of respond if we implement DDMRP? So I think Chad, if you can take a stab at this.
Well, I think responsiveness in the VUCA world is key. What DDMRP does differently is that it disconnects forecast from supplier to generation, and that's where we get into trouble with the VUCA world. So the answer, I guess, to this question is no. Do not do that either at the daily or weekly level if you're connecting your forecast to supplier to generation. And instead, what DDMRP does is it connects anticipation or anticipated events, including an anticipated rate of demand. It connects that to the shape of the buffer, but the ordering mechanism inside the buffer uses only real demand.
Okay, very good. Next question, please. You mentioned some case studies, Andre. I guess that was you as part of your presentation. Is there a way to get more information about these and learn about them?
Thanks, Gerrit. Yeah, certainly. So you can visit the Demand Driven Institute website, and under the case studies section, you'll find some examples that I've mentioned, as well as many others. There are also videos about these case studies from the Demand Driven World Conferences. And the specific case studies that I refer to are from Coca-Cola South Africa, PPG in Latin America, Mega Elementos, and SAPA. And also, this is the first of a series of webinars on this topic. So therefore, there will be more content that will become available. And also, if anyone is interested in more information or more examples or demos on what was discussed today, you can always reach out to Foresight or Simio as well.
Thank you, Andre. I think that's good. Those case studies are live video recordings of those companies you mentioned, so to give all the insights, the detail, how it was implemented, and how they measured success. So I think it's really great. Next question, please. So with regards to Simio, is that an easy way to show the dashboard's results and information to workers, planners, managers within the manufacturing facility or distribution centers if they don't know Simio, right? So I think all those things that you shared, Christine, is is it easy for people to see that?
Yeah, Garrett. So what we looked at in the demonstration is Simio on a desktop, and we have a web-based Simio portal as well. So once the model is developed and the dashboards have been developed, as we saw, we can upload a model and run it on a daily or a weekly basis, and push out those dashboard results to the manufacturing facility, to managers in the warehouses. And the nice thing about those dashboards too is that they can be they're customized, and they can be customized so that particular warehouse managers only see what pertains to them. So same thing within the manufacturing facility. So you're not having to sort through some of those dashboards that you might not be interested in or that don't apply to you. Those, they can all be really customized and sent out to the right people at the right times. And those can be done on a more kind of a scheduled basis.
Yeah, I think that's a good point, that the dashboards will be role-based, right? So if you the planner and you want to see the planning view, that is what you will see. If you the warehouse person, you can see your warehouse capacity outlook for the next 2 weeks, 6 weeks, 6 months, if you want. All right, can we get the next question on the screen, please? So the Simio digital twin seems like it can be used for short or long-term planning. I think the question is it the same model, and how to adapt it to longer range, right? And what can be done to plan ahead for something like a promotion or new product, right? So I think, is this all one digital twin, or is it 2 or 3? I think, Christine.
So as we saw in the example, it's one digital twin based on your facility or your system, and really, it's just about the data that you bring into the system. So as I mentioned, the example comes with the Simio software, and you import the data. So you've got your resources, your routings, and sales orders, and so on. And so whether you run it for a shorter period of time, a few weeks, or longer strategic planning, it's the same model. You can also adapt it so that you might have kind of what we call a model property that allows you to turn off things like workers for those long-term strategic planning type of runs, because you're going to do staffing a year or a year and a half out. And you're more looking at, can my resource capacity, can my factory handle those kind of things? And so, yeah, that's the great part about the digital twin, is it's truly data generated and data driven.
Thanks, because I think, Chad, just to extend on that. So some people might sense that it's sort of only valid in the sort of fixed order operational window, but I think there's a little bit more to that for looking at the tactical and the strategic time frame as well, right?
Yeah, I think one very big difference between what people would characterize as the conventional approach and what we're doing on the demand-driven side is that we don't have a master production schedule. Instead, what we use are what we call master settings, which are the model configurations. So the model configuration is all about the tactical and strategic view, and particularly, if we're looking at strategy, we're looking at where we're decoupling, where we might decouple in the future. Tactically, we're looking at what are some short range or some tactically ranged events that we anticipate. And we define the operational, tactical, and strategic horizons. We can define them very discreetly in a demand-driven model. So and it's also a really unique kind of attribute that we have.
Okay, very good. Next question, please. We're running a little bit over, but I think we'll take one or two more. It looked like from the expanded supply chain example that a digital twin of the larger supply chains can be generated. If you have data for the distribution centers and suppliers, is there a limit to what can be included in this model? And also if things have long lead times, sometimes if things come from the east, it's 3, 4, 6 weeks. So I think Christine, from a digital twin perspective, are there any limits?
There aren't. We have, in that example we saw, we just used a single distribution center, but the more sites you include, it basically is going to handle the transfer of material from whatever upstream supply chain, whether it's multiple factories or multiple suppliers. It's really more about the data, and I think that the data, that we run into, any issues that would be, having the data available is typically a bigger issue, not for the model itself, but for the companies to provide that data. Sometimes can be an issue. And yes, we do handle supply chains that have longer lead times as well. Things like, if you're pulling from other countries, pharmaceutical has a lot of, multi-level supply chain where the lead times are much longer, and we can handle that as well.
All right. I think let's do a final question here. So this is interesting. In your experience, how steep is the learning curve for users with a manufacturing relation background compared with supply chain professionals when using Simio for DDMRP, right? So I think I will split this last one in two. Perhaps give to Chad first, right? Just an experience for people to adopt DDMRP, and then I think the second one, Christine, to you is from a learning from a Simio or a digital twin perspective. What is the challenge? So Chad, just your sense as to, for companies to adopt DDMRP, what does that look like?
Well, we have a saying. We say thoughtware before software, or rules before tools. It's crucial. I mean, what we're doing on the demand-driven side is different than convention, and so it really does require people to fundamentally understand what we're doing and why we're doing it. I think that's really important. It's easy. I think it's easier to understand what it is. It's harder sometimes for people to understand what the compelling need for change is in the VUCA world. What are the mechanisms in conventional planning that are really leading companies down a dangerous path? The VUCA world will spoil your party very quickly if you continue to plan like it's 1965.
Well, I think it's a valid point, and I think, Christine, the question here is it hard to build one of these digital twins? And I think perhaps you can address a little bit sort of the template approach and how that what you've showed, might help to shorten this process.
Yeah, Garrett, that's the hope. With that example, that model that we have a number of templates that have demand driven in them. For example, we've got a one that's specifically for mixed tank fill type of operations, which are different than the discrete parts type of production that we just saw in the example. But by having a template that has got all of the different data tables where you would import your data, and it's got the majority of the logic that's included underneath, as well as the dashboards included with it. It makes it much easier. And of course, you can always expand on that, as I mentioned, with things like our workers and vehicles and additional, if you have material handling within the factory, that can always be expanded as well. But to Chad's point, I think that one of the key things is it's great if you can use the template and you are knowledgeable in Simio to start with a DDMRP project. But it's also the most, I think, important thing is to understand the demand-driven methodology in general and how the master settings feed into those different buffer zone sizes, why you're doing that, and what the methodology kind of stands for and how it's implemented in the first place. Just know Simio and use the template. You can do it, but it's important. It's important to understand the philosophy.
Sure. No, thank you. I think this is the end of our questions. I think just up next is what is coming. We've got a nice 3-part series that we're going to do on October 20th, November 13th, and December 11th. So please note that down in your calendars, and we'll get into more, as Christine just said, and is that sort of detail. Why, how variability impacts your world in terms of planning, scheduling, and your business performance. And sort of the challenges, the next one is the challenges that it puts on your current systems, right? And why you have some issues. And then sort of the last one is to sort of dive into, this whole question of managing and protecting flow, and specifically using DDMRP. So with that, thank you to the speakers, Andre from Foresight, Christine from Simio, and Chad from the Demand Driven Institute. Thank you very much, and have a nice day.